Hi, everyone. Welcome to the session. We're going to talk about the reverse stress testing with agentic AI. So for the agentic reverse stress testing, what's involved is a failure point identification. So typically, you would have the banks who has the portfolio, and you want to identify the failure modes and the different types of failures that can happen within the portfolio. And once we have the failure points, we want to identify the risk factors that are going to cause these failures. And once the risk factors are identified, we want to generate alternate scenarios and then generate, evaluate the portfolio for these different alternative scenarios. So how we are going to do this today is we're going to use the SaaS integrated risk platform. You might have seen in the earlier sessions here where within the stress testing platform that's used for risk assessment, we have the process for data processing and then the scenario management and the business assumptions that are captured and the risk measurement. So we have this typical process, and what's important is we have the objects that are necessary to perform AI-enabled risk assessment as well as the reverse stress testing. So we're going to use this framework today to showcase how the SaaS stress testing solution can be used to do a reverse stress testing. So this is a typical cycle where we have the different steps in the stress testing process. We're going to leverage the process we have and extend it to do a failure point analysis. Also, we identify the shocks, and we'll be evaluating the portfolio for these shocks. So let me show how we can do this. Okay. So this is what you're seeing is the stress testing solution. And to your, like on the left, we have the different objects we have within the stress testing solution. And what we are seeing are the analysis runs. These are typically performed as part of the stress testing exercise. And we are extending this with the reverse stress testing functionality today. So to do that, I have the reverse stress test agent, and it's going to, as I prompt, I'll be walking through like different prompts. And at first, I'm going to ask for the results that are available in the stress testing exercise. So it's going to, when I submit the prompt, it's going to provide the results that are available in the solution. So this is an example where we are prompting the solution, and it came back with the results here. So within the solution, we have different data sets, and when I prompted it, it came back with the results that are needed for performing the reverse stress testing. So here we have the stress test, the loss distribution summary results here, and we're going to use this to perform additional analysis today. So let me continue with the prompt, and it came back with the prompt came back, and I can, this is the result set which I'm interested in. So I can use this particular result set to further query and perform additional analysis on this result set. So I'm going to submit a prompt to summarize the data set. And when I do that, the agent is going to look into the data set that's already available in the solution and query and come back with the results, where here we have the different scenarios that already stress tested on, like the adverse scenario, and then we have the severe and the base case scenario. So these are the values, the expected loss, the value at risk, and the economic capital that's already computed as part of the stress testing cycle, and they are being retrieved and displayed to the user. So this is the result set that we are going to use to further do failure point analysis. So this is the way to query the solution to get the results for a particular result set. And once we have the result set, we can, as you can see, these are the different scenario and then the portfolio, and we have the metrics, the risk metrics that we are going to use to perform the evaluation. So as the next step, once we get the results, we can further prompt the solution. So in this case, we do the failure point analysis where we're going to, the agent is going to, once I submit the prompt, it is identifying the threshold based on the data that's already available in the solution, and it came back with the results. So what it did is prioritize the portfolios, and based on the threshold value we already have in the solution, it identified the portfolios which are more at risk and came back with that result. So with that result set. So this is an example where you want to identify where is the problem in the portfolio, which is more prone for failure. So this is a way to query the stress testing solution and come back with the results. So now we got the results, and what we can do is further evaluate the portfolio. So we can do that by submitting another prompt to do a marginal portfolio evaluation. And when I submitted the prompt, it's looking at the portfolio and these particular the particular portfolios which are more at risk, and calculating the risk factors that are that would most likely have these portfolios exceed the loss threshold we had submitted. So when I submitted the prompt, it did multiple steps. It calculated the risk factor shocks, and then it generated a scenario for with the shocked values, and then it created the analysis run. So all of these steps happened when I submitted the prompt to do the marginal portfolio evaluation. And right now, it is just using the values that are already available in a stress testing cycle. So when as part of this, it came back with this, and it created the analysis run. And all of this is happening within the solution. So the analysis run is generated, and as you can see to the left, we have the different analysis runs that were already created. And now there's a new analysis run that has status of in progress. And we can look into the analysis run itself. So when I clicked on it, we have the analysis run details. So within the typical analysis run, we bring together the portfolios, scenarios, and also the other assumptions that are required to evaluate the portfolio. And all those objects that are typically fed from within the solution, within solution UI, these have been created automatically by the AI agent. And this is the scenario that was created, and it's being used to perform the analysis run. So we are using the framework of the solution to perform additional analysis. So this is how we are capturing the additional scenarios and then using them again to create another analysis run to provide more insight. And these are the shocks that were generated. So if we look at the, I continue. So we have the different shocks, and we can look into the particular shock that was generated, and I can click, I can refresh, and these are the new shock that was created, and I can further look into the shock and look at the shock factors that are used, that were calculated by the AI agent, and I can look at the shocks and then come back, and now when I look at the status of the run itself, it's been executed, and it was successful. So this framework we can use to perform the additional analysis. And the results of the analysis run themselves are available in the solution, where we typically look at the results of the run as a credit risk, credit stress testing summary, where we'd be able to look at the previous run as well as the new run that was submitted. So this is the original run where we had the 3 scenarios, and these are the loss metrics that were generated as part of the run. And we are using the same framework to create a new run, and the results of the run are again available within the solution. So this was what was originally run, and based on this, we created a marginal portfolio and evaluated that portfolio. And the results of that are again available within the solution. And we have now we have a severely stressed scenario, and the loss values are far more than what we had earlier. So these are, we created a new shock scenario and then evaluated the portfolio. In this case, we are looking at the marginal portfolio and looking at the loss values that would be that we'd see if this marginal portfolio was stressed. Now, not only that, like we have the capability to perform additional additional analysis where, so earlier we were using the loss threshold value from the different scenario runs we had in the solution. Now we can provide additional loss threshold. Like in this case, I'm looking at 30 million loss threshold and then submitting another run. So this way, it gives more flexibility to the user to look at how the portfolio would behave under different loss threshold values. So this is very useful to perform what-if analysis within the solution. And when I submitted the new loss threshold, again, it went through the same steps. It calculated the loss threshold, the risk factor shocks that are needed for the loss threshold value, and then it created a shocked scenario, and then it created a new analysis run. So we are reusing the objects within the solution to perform the additional analysis. Now, again, just like earlier, we have a new analysis run that's been created, and we can again look at the objects that are used for the solution, used for the analysis run, and the new shocks that are generated for this revised marginal portfolio loss threshold value. So this kind of analysis is possible within the solution. Okay. So earlier we looked at the loss threshold, the marginal portfolio elevation, and we can also perform additional analysis. For example, this is another use case where I did a failure point analysis, and then after the failure point analysis, I wanted to look at the aggregate portfolio. What is the shock factor that is needed for a aggregate portfolio loss? And I gave a different prompt here where I wanted the agents to evaluate the aggregate portfolio for failure for a given loss threshold. And it's going to use the same mechanism as earlier, but with a revised set where we have a different loss threshold, and we also have the different, we are looking at the entire portfolio, because sometimes, even though there could be a portfolio that's sensitive, you still want to look at overall what is my entire portfolio going to do. So when I can use a different analysis using the same steps, but by providing different prompts and different threshold values, I'm able to perform the same analysis here. So when I do the analysis, again, it created, when I prompted, it again created an analysis run. And now we have the results for a different set of assumptions that we are looking at. So this is how we can perform the reverse stress testing within solution. And we have additional flexibility. So we have, this is an example where we have the example. So we have the failure point analysis. And earlier when we submitted the failure point analysis, we had uh, it came back with 3 portfolios for the threshold value. And now, if I want to change my failure point, I don't want to use up all the economic capital that I had allocated. So I can, again, prompt with a different value. Like, for example, I said, for a risk appetite of zero point 0.9, give me the portfolios that are going to match this loss. And it came back with a revised set where now we have 2 portfolios. So earlier we had 3, and now we have 2, for which the credit VaR is going to exceed the threshold I have set. Similarly, so you can perform like another run where I changed the assumption to have a risk appetite of 0.75, and it came back with a revised portfolio whose loss threshold exceeds the values that I had submitted earlier. So this kind of different analysis is possible within the solution. So moving on. So in summary, like what we had done is we used the solution framework. We used the different objects within the solution and performed the additional analysis. So from a reverse stress testing point, we are looking at what are the potential failure points, and then what are the risk factor shocks that can cause these failures, and created the shocks, and then we submitted, we were able to, just by prompting, create an analysis run where the solution is going to look at the revised shocks and perform the analysis, and then the results are available within the solution. So we are pretty much reusing the framework we have within the solution, and the important point is the objects we have in the solution are enabling us to create the agents that would perform this analysis. So it's not just the agents, like what's key is the underlying platform that's enabling this, and that's how we are able to use AI to perform additional what-if scenarios within the solution. And using this, we have additional benefits like we are reusing the data and creating additional data sets that we can use, and this would significantly reduce the number of iterations, the number of people, and the number of hours that we would have to typically use for this kind of analysis. So in summary, this is how we have, and as was discussed in the sessions yesterday, so it's not just the AI capabilities, it's how we use the AI and then generate the results and validate that they are meeting our business objectives. So that's the key. So we can just rely on AI, but we are using the AI capabilities to perform additional analysis. And here we are using AI to generate the scenario shocks, but we are, again, testing those scenario shocks using the analysis runs within the solution. You can think of this as you use the AI to generate, and then you, again, verify with already laid methodologies that you have in the organization. So just an acknowledgement, like we have team members from the SaaS R&D team and the risk fraud compliance team who have helped in creating the content that I have presented today. Okay, that brings me to summary.
Thank you, Siva. Time for some questions here.
Thanks, Jonathan. Thank you very much for the presentation, really interesting. So apologies, I joined a couple minutes late, but did you cover in terms of the agent creation component, how we make sure that the agent sort of produce intuitive result, and then do we have the the capability essentially within the sort of the SaaS environment to basically ask the agent to articulate how it got to that solution or how they got to the reverse stress scenario?
Right. Yeah, I haven't covered. I think the question was about the underlying process of how the agents are working. I did not cover the underlying technicalities behind this. I was solving the business case here. But I can explain like what's happening here is at first when I chose reverse stress test task, it's actually a supervisor. And then this supervisor works with different agents. So I have an agent for data, working with the data, working with the risk data. So this agent can have like business rules about how to look at the risk data, right? Where when it aggregates, should I look at the sum or other methodologies? So I had the agent for that, and also have an agent for scenario generation, and I also have an agent for analysis run creation. So there's a supervisor, and this supervisor coordinates these agents depending on the prompt that I had, and that's how these agents work. And where LLM is being used is when I describe a supervisor, it's in almost like plain English, right? And LLM is able to interpret this plain English language as a sequence of tasks for the agents to execute. So that's the underlying mechanism of how it's working.
Thanks. You also answered part of my questions, but I have another question. So you shows the Copilot. We have a SaaS via risk engine. We will have also Copilot implemented in our platform. Do you need anything else in order to do what you are currently doing? When I say anything else, any other modules SaaS created or?
Yeah, I think the answer is like what we have is the Copilot, like the Via Copilot, and that's the additional module that sits on top of that, and it works. The underlying risk platform has you can think of it as an extension for Copilot, and that underlying risk platform Copilot is working with the risk engine. So when I submitted an analysis run, in the background, it created a risk engine run. And that's possible because of the extension we have in the risk platform.
Okay.
Any other questions? No? Yep.
The agents that you mentioned earlier, did you build them or did they come with SaaS?
So the question was the agents that are built, did I build them or did come with SaaS? So the underlying core functionality is provided by the risk platform, and the coordination of the different agents to perform these tasks, they are relevant for a solution. So that's the part that I had built for stress testing solution. But the core functionality like data management or the scenario generation or the analysis run creation, they are part of the risk platform.
Sorry, just a quick question in terms of the runtime. So the demo that you've shown sort of literally ran in minutes. So in a real life scenario, like
Right.
what is the type of runtime with a sort of a mid-sized commercial bank roughly?
Right, that's a good question. I think the question was about the runtimes that are typically needed for a portfolio evaluation. This would be similar to what you would like in a stress testing exercise. If you submit an analysis run, the time it would take, right? It would be similar to that, and that's why it's when I had the run, it's more like it is generating the run, and then we had the analysis run as part of the UI where it says in progress. So the times you would expect would be similar to what you would typically see for an analysis run.
And presumably with Via and the cloud services, you can run multiple jobs at the same time.
You can
Yeah.
submit multiple analysis runs at the same time.
Okay. And when you say risk infrastructure, is there a particular product that you're sort of referring to from a SaaS perspective? Because we've got Via as well, and this looks very exciting. Just curious in terms of what other.
Yeah, in
packages
terms
will
like
be-
we have so the SaaS risk solutions like ACL, we call it Allowance for Credit Loss, SaaS stress testing, SaaS ALM. All of these run on an underlying risk platform. So when I mentioned the RISC platform, I was referring to these capabilities provided by the platform. Yeah.
All right. Thank you so much, Siva, and thank you all for attending.